All right, guys. So, if you're watching this, it's because I wasn't able to attend class, or perhaps you were absent from class. Okay. Um, so, I'm going to go over a couple of things that we didn't get to go over in class. Okay. So, the first thing I want to cover is for those of you who took notes on this. I know this is mostly for my second period pre-AP class. Guys, I said we'd continue to add on to this as the week went on. Okay. So, if you can go ahead and copy down the new things that I added here. Okay. The first thing you should notice is this part right here. Okay. So, ionic bonds, they tend to be formed between nonmetals and metals. Okay, now I put a charge next to each of those words because the nonmetals tend to be the negative ion and the metals tend to be the positive ion. Okay, so please be sure to go ahead and add this section right here. And then down here, okay, I added a few more tabs. Okay, so the first one is that metals generally are the positive ion, and I mentioned that up here. Okay, and nonmetals are generally the negative ion. Okay, now there are some exceptions to this. Okay, there are some exceptions, and we'll learn about those further down the line. Okay, but right now we're just going to stick to this. Okay, metals are positive, nonmetals are negative. Okay, excuse me. We're going to go ahead and move on to this next tab here. Okay, so guys, basically what I'm going to be doing in this video is just adding another layer to your understanding of ionic bonds. Okay, because really right now that is the focus of class. It's ionic bonds, ionic compounds. We're not at covalent bonds yet, so for now we're simply focusing on ionic compounds and ionic bonds. So again, just trying to add another layer, okay, to your understanding of ionic compounds. Okay, and what I have here, okay, I basically just wrote down what we have on our notes here. Okay, the reason why I did that was so I don't have to keep going back and forth between the tabs. Okay, again, bonds are formed from electrostatic attraction. Okay, and I should have put ionic bonds. Okay, ionic bonds are formed from electrostatic attraction. Okay, remember that's similar to magnets. Okay, where we have a positive end and a negative end, and opposites attract, right? So in ionic compounds, it's generally between a metal and a nonmetal, right? Metals generally are the positive ion, nonmetals are generally the negative ion. How do they get to that point? Well, metals have a low ionization energy and they're more than likely to lose electrons. Nonmetals, on the other hand, have a high ionization energy and are more likely to go ahead and gain electrons. Okay, now you're looking at the periodic table and you want to be able to tell real quick, generally speaking, where our metals are and where our nonmetals are, as you can basically use this step right here to separate. Okay, now some of these elements here are considered metalloids, like silicone, for example. They kind of blur the line between metal and non-metal, right? But generally speaking, okay, if you're on the right side, or I'm sorry, the left side of this staircase, you're a metal. Okay, if you're on the left side of the staircase, you're a metal. And if you're on the right side of the staircase, you're a non-metal. Right, so if you're on this side, you probably have a high ionization energy, which means you're more than likely to gain electrons. But if you're on this side of the periodic table, you more than likely have a low ionization energy, and you're more than likely to lose electrons. Okay, so that's just a quick little reminder, okay, for figuring out what is what. Okay, again, metals on the left side of the staircase, and our non-metals are on the right side of the staircase. Okay, all right, so moving on. Okay, moving on. Okay, we're going to go ahead and take a look over here. Okay, we're going to go ahead and take a look over here at the Bohr model. Okay, and what we're working with here is lithium and fluorine. Okay, so what I want to illustrate for you guys is what exactly is going on, okay, in an ionic bond, okay? What exactly is it that's behind the formation of an ionic compound? Because when the stuff that we worked on earlier, I just showed you guys how to balance charges, but I didn't really show you what is really taking place here, okay? So we have two elements here. We have lithium and we have fluorine, okay? Now, one of them's a metal and one of them's a non-metal, okay? So by now, we should know that lithium is the metal. Let me go ahead and, yeah, we'll just go ahead and write it like that. Lithium is a metal, right? And fluorine is a non-metal. Well, if there's anything we learned just now, it's that metals tend to lose electrons because of their low ionization energy, right? So lithium, being a metal, is more than likely going to lose an electron, right? And on the other hand, fluorine, okay, being a non-metal and having a high ionization energy, it's likely going to gain an electron, right? So we're going to go ahead and write that in here. It's going to gain, that's not the same color green, gain an electron, okay? All right, so we've established what's going to happen, okay? Lithium, being the metal, is going to lose electrons, one or more. Fluorine, on the other hand, is going to gain one or more electrons, right? Well, I drew the Bohr model here, guys, because it's a really nice example, provides a really nice illustration for us to understand what's going on here, okay? So we have lithium here, and lithium has a total of 3 electrons, with 1 electron in its valence shell, its outermost shell. Fluorine, on the other hand, okay, it also has 2 shells, and in its valence shell, it has 7 electrons, okay? So you could think of both of these elements as just being extremely unsatisfied, okay? They're just pissed off, okay? Because lithium, okay, it only has 1 valence electron, okay? It's 7 away from having a full shell, okay? Fluorine, on the other hand, has 7 electrons, but it's missing 1, okay? So only 1 electron is preventing fluorine from having a full shell. So what's going to happen here, okay, is these guys are going to use each other, okay, to satisfy what they're after, and that is having a full shell. Remember, that's the ultimate goal, okay? Atoms always want to have a full shell, okay? So we're going to go ahead and show what happens here, okay? Fluorine needs 1 more electron, right? It's missing this 1 electron. And lithium happens to have 1 electron that it needs to get rid of. So here's what's going to happen. Lithium, having a low ionization energy, meaning it'll lose electrons, is going to lose or give away its 1 electron to fluorine. And when that happens, fluorine ends up gaining that 1 electron. And as a result of that, fluorine obtains a full valence shell. Okay, now fluorine has a full valence shell. It's satisfied. Okay, it's what we call, where I said it's happy, because it now has a full valence shell. Okay, what about lithium? Well, lithium now has an empty, okay, second shell. Okay, what used to be the valence shell is now empty. So what's going to happen? Well, basically, this shell goes bye-bye, okay? Theoretically, it's still there, but it doesn't have any electrons occupying it, right? And as a result, right, what it ends up with is a full valence shell. Remember, in the first shell, you can only fit up to 2 electrons. So technically speaking, it now has a full shell, okay? So I'm going to go ahead and bring back that shell right here, just for the sake of these different models that we have, okay? So this is what we end up with down here, okay? Fluorine, okay, has 2 electrons and a full shell. Over here, okay, fluorine, I'm sorry, I called this fluorine. This is lithium. Lithium has 2 electrons in its first shell. It's full, okay? And fluorine obtained an extra electron, so now its valence shell is full as well. Okay, so here's what we have. Here's what we have, okay? I'll go over this one more time real quick, okay? Lithium's a metal. It has a low ionization energy. It only has 1 valence electron that it desperately wants to get rid of so it can obtain this full shell. Fluorine is a nonmetal and it has a high ionization energy, meaning it's going to gain electrons, right? So fluorine happens to only need 1 more electron. Lithium happens to have 1 electron. Lithium very happily gives its 1 valence electron to fluorine. Fluorine obtains a full valence shell and it's now happy. And lithium has now obtained a full shell. Remember, the first shell can only fit up to 2 electrons, so technically it's full. And now as a result of that, lithium, I was going to write lithium. Lithium is happy as well, okay? Now, again, this was just an illustration showing you guys what's happening here. So we're not done just yet, okay? Because we need to show what forms the bond, right? So what's happening here, okay? We're gonna simplify what we have here, okay? Lithium has gained a positive charge, right? Because now it has 1 more proton than it does electrons. So now it has 1 extra positive charge. So we're going to say lithium is this atom here with a positive charge, all right? And we're going to draw it just like that. And then fluorine over here, okay, is this element, okay, that's gained 1 electron. So now, okay, it has a total of 10 electrons to its 9 protons. It has 1 extra negative charge. So we're going to write a giant 1. We're going to write an atom here with a -1 charge. Well, look at that, guys. If we go back to our example of the magnets, where we have opposite charges, that's exactly what we have here. And what happens when we have opposite charges? Well, opposites attract. So really what we end up with here, okay, due to the electrostatic attraction between oppositely charged particles, yeah, that's a mouthful, we have a positive 1 ion. Let me do it this way. We have a positive 1 ion. I'm just going to go ahead and copy this. Coming together with a -1 ion, and they form a bond. Okay, and there's our ionic compound in a model format. Okay, these two have come together and they've formed an ionic bond. And this is what we call, go ahead and write it in different color here. This is what we call lithium fluoride. Now, don't worry about naming. We're not practicing that right now, but I'm just going to give you the name to this compound here. This is lithium fluoride. Okay. Now, we're going to do this one more time, but we're going to do it using Lewis valence dot models. Okay. So we're going to come up here. All right. Remember, this is just a shorter version of the Bohr model, right? Where we're only looking at the valence shell. Okay. So let's go ahead and see what we're doing here. Okay. So lithium, there's lithium's 1 valence electron. Here's fluorine's 7. Lithium is a metal, has a low ionization energy. It's willing to give up electrons. Fluorine has a high ionization energy, and it's willing to accept or gain electrons, right? And so similar to what happened over here, we're going to show the same thing. Okay, so lithium takes this 1 electron and gives it away to fluorine. So now we can rewrite this as Li 1 plus, and fluorine, all right, I'm still going to draw the valence electrons just so it's illustrated here. Fluorine has now gained 1 electron. And as a result of that, fluorine gains a 1 minus charge, right? Now, same thing, okay? We have oppositely charged particles, okay? Oppositely charged particles attract, right? And so what we have is lithium with this 1 positive charge being attracted to fluorines, and this is actually the fluoride ion, but again, we'll get to names later. It's attracted to fluoride's 1 minus charge. And again, what we end up forming is LiF. Okay? That's how we show it. Now, you might be thinking, Mister, you know what? I'm a lot more comfortable writing that table where we have the positive ion over here and the negative ion over here. Okay, that's fine. Okay, but again, that doesn't really show us what's happening. This is just to balance charges out. Okay, this illustrates what's really going on. Okay, and why these compounds come together. Okay, so again, that's great that you understand the concept of balancing charges, but that's not what this video is about. This video is about illustrating it's about providing more context behind the bond. Okay. Now, this next part I didn't actually include, so I'm just going to kind of do it on the spot. Okay, so it might be a little bit slower and not as smooth as these other parts over here. Okay, let's say that we're trying to put together magnesium and fluorine. Okay, so I'm going to draw another line right here. Okay, so we have magnesium, right? And then I'm going to take fluorine again. Make this a little bit larger. All right. And we have that, so magnesium and fluorine, and we're going to write down magnesium. All right, let's look at the periodic table here. Magnesium's right here, right? So Mg, it's in the second period. It's going to have 2 valence electrons. All right, so we're going to write Mg, and we're going to show magnesium with its 2 valence electrons. And then we're going to do the same thing for fluorine. All right, and here we are. Oh, don't want to do that. I'll just leave it like that. Okay, so what's going to happen here? Okay, well, we have to use what we know, okay, and that is magnesium is a metal. So it's likely to have a low ionization energy. And if we were to pull up the chart, we would see that it does, okay, have a low ionization energy. So we know it's going to lose electrons, right? With fluorine, well, we already know from our previous example, it's a nonmetal. And it's likely to have a high ionization energy. And again, it does. So it's likely to gain electrons as a result of that. Okay, now what's going to happen here? Okay, well, magnesium, okay, has these 2 electrons that it can give away, right? We already know that's going to happen because it's a metal. Okay, we have fluorine here, right? But it only needs 1 valence electron. It doesn't need 2, right? So what's going to happen here? What do we think is going to happen? Because again, remember, if magnesium were to lose these 2 electrons, it would have a positive 2 charge, right? If it were to lose those 2 electrons, it would have a positive 2 charge. And if fluorine were to gain 1 electron, because it can only gain 1 electron, fluorine would have a 1 minus charge, right? But so my point is magnesium can't give both of its electrons to fluorine because fluorine only needs one more electron, right? So you guys are probably already know what's going to happen, right? But if you don't, let me go ahead and illustrate it down here. Okay, so I'm going to write magnesium and keep it in the same color though. I'm going to write magnesium right here. I'm right in the middle. Okay, and I'm still going to include its valence electrons here, but I'm going to write them on one side here, and then one over here. Okay. Now here's magnesium, right? And then let's go ahead and take our fluorine ion, fluorine and fluorine, right? Now let me just go ahead and drop this electron over here, so it's going to make more sense. Okay. Well, maybe looking at it like this makes a little bit more sense, right? So what's going to happen here? Well, this guy can take one electron, and this fluorine can take one electron. And so that's what we're going to see happen. Magnesium is going to give one of its electrons to this fluorine, and then magnesium over here is going to give this guy, this electron, to this fluorine. And as a result of that, we form magnesium 2 plus, and we form, sorry guys, I keep meaning to keep these guys in the same color. I'm sure it doesn't matter to you, but to me it does. All right, so here we go. We now have a fluorine with the 8 electrons it wanted. All right, same thing over here. Take this guy, let's go ahead and drop it right here. And now these guys both have a -1 charge, right? Both of these guys have a 1 minus charge, okay? Now, what did we learn from the table? Okay, we learned that we have to make sure that these charges balance out, and of course they do. -1 and -1 is -2. -2 plus +2, that takes us to 0, right? So what's happening here is these guys are forming a bond, right? They're forming another bond. And so the way that this is going to look, if we were to draw it out similar to how we did right here, okay, what you would have is magnesium, right? Magnesium with a 2 positive charge. And then what you have here is fluorine, and these fluorine atoms are actually going to be a little bit smaller. All right, both with a 1 minus charge, okay? And this would be how the molecule would look to some extent, okay? You might be thinking it looks like water. Well, that's because the compound that we formed, okay, is MgF2, right? So that's what we do here, okay? That's basically the context behind the formation of ionic compounds, okay? So in the assignment for today, okay, whether you're given elements that balance out nicely, like lithium and fluorine, or elements to where they don't exactly balance out nicely, like magnesium and fluorine, okay, I need you to go ahead and draw the valence dot model for the anion and the cation, okay? Show them with their charges, all right? And then show them coming together to form the compound. Now, you don't have to do this, okay, if you don't want to, but I do need to see the formation of the compound, okay? This right here, this is extra, okay? Not extra credit. I'm just saying like it's extra as in like if you want to go that additional step just to visualize it, you can, but you don't have to, okay? What I want to see, again, is you writing out the Lewis dot structure, okay? Is it a metal? Is it a non-metal? Yes, no, okay. Whatever it is, what happens? Does it lose or gain electrons? You need to indicate that as well. Then you need to do what we did down here, okay? Show the transfer of the electrons, show the formation of the charges, and then show the final compound that forms. That is what you're doing today, all right? Hope this video made sense. My pre-AP, my 7th period pre-AP class, okay, you guys, if you have a question on this, okay, feel free to send me an email, all right, but I won't be able to answer your email until I'm done with testing, okay? So don't expect an email from me until that evening, okay? My 2nd period pre-AP class, you guys are gonna be getting this tomorrow. If you have questions on it, again, shoot me an email, okay? All right, thanks guys. Hope this video made sense. Go ahead and let's see here, stop recording.